back. Today's topic is problems on computation of electrostatic field intensity. In the last video lecture, we have gone through Coulomb's law, computing the forces between the charges, point charges, and we have also seen the expressions which are to be employed for computing electrostatic fields. So in today's class, I hope that by the end of this video lecture, you will be able to determine the electrostatic fields intensity due to different types of charges, point charges and also uniform charge distributions. Now, moving on to the first problem. The first problem states that three equal positive charges of 4 nanocoulomb each are located at three corners of a square with a side 20 centimeters. Now you are supposed to determine the magnitude and direction of the electric field intensity at the vacant corner of the square. So see, there are three charges, and at the vacant corner of the square, you are supposed to determine the field. Now let us suppose if I take square is basically a two-dimensional object, so I will consider z component as defaultly 0. So I'll take x and y coordinate system. So I'll consider a square like this. A, B, C and D. See, the locations of these points, I can write it as 0, 0, 0, and B is 0, 20, 0, C is 20, 20, 0, and it is 0, sorry, 20, 0, 0. Okay. So these indicate the dimensions of the square, the vertices of the square, and they are saying that three equal positive charges are located at 3 points. So I'll take three charges, Q1, Q2, Q3 at three corners of the square, and at this point I want to determine the electrostatic fields. So here I'll be getting one, sorry. So if I consider this one, I'll redraw the figure again. So there are 4 charges, Q1, Q2 and Q3 at A, B and C. So from A, the direction will be along the line joining A and D. From B, it will be like this. And from C, it will be like this. So this is E electric field due to the charge A. This is electric field due to the charge B. This is electric field due to the charge C. So the net electric field is the summation of these electric fields in vector formats. So I will start with the electric field due to the charge A. Before going for this computation of electrostatic fields, I would like to clear one thing for you. It is always a tedious task of how to determine the vectors, because electric field is basically a vector. So determining the unit vector is one biggest thing, because electric field equation due to a point charge itself states that this is C. So it indicates electric field due to the charge A at point B. So if Q1 is a charge which is placed at A and D is your point of consideration, then this is the equation for determining the electrostatic field intensity at the point B. So in this one, if you carefully see, this is the unit vector which is governing the line joining A and D. So how to determine this unit vector? Different textbooks follow different notations, but let us stick to this one particular notation throughout this course. So let us suppose if you do have 2 points, x1, y1 and z1, and x2, y2 and z2. Now how to determine the unit vector which joins 1 and 2? So in this case, what we will do from now onwards in this course, we will take it as x2 minus x1 into I bar plus y2 minus y1 into j bar plus z2 minus z1 into k bar. Z2 minus Z1 into k bar by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. We will stick on to this particular representation from now onwards. Okay, so in this equation, now we are trying to compute electrostatic field due to the charge at A on the point D. So the formula is very simple. We know the formula. It is 1 by 4 pi epsilon naught epsilon r, which is a proportionality constant, into the charge. If it is a point charge, we will directly take it as a charge, by d square or r square, whatever it is. Distance between the point where the charge is located and to your point of consideration into u r bar. So this value epsilon r, it has been mentioned as 1. So epsilon naught value, you know it. Q value has already been given for you, and the r value, very simple. You can directly take actually the unit vector itself, whatever the denominator which you get, it is basically the distance, right? So it is just like your A point is now 0, 0, 0, and your D point is now your D point is, I think it is 20, 0, 0. I think, let me check once again. Yeah, D point is 20, 0, 0. So you will get square root of the distance between these two is 20 square plus 0 square plus 0 square. It is 20 centimeters and it is 0.2 meters. So this is the distance, and substituting all these values, epsilon value, epsilon r value, the charge, the distance, and the unit vector. Unit vector I have already told you, since these two are the points, this is the A point, this is D point. So 20 minus 0 into I bar, we will follow this notation from now onwards. 20 minus 0, 0 minus 0, and 0 minus 0. I, j, and k. Square root of this component square plus this component square plus this component square. So the final answer which you will be getting is plus 900 I. Okay. Now we will move on to the second one, where we do have a charge at B. The location of B is 0, 20, and 0. And D point is 20, 0, 0. So the distance between these two is RBD is equal to square root of 20 minus 0 whole square plus 0 minus 20 whole square plus 0 minus 0 whole square. You will get around square root of 400 plus 400. It is 20 root 2, which is equal to, if you convert it into meters, you will get 0.288 meters. Okay. Now this is the distance. The charge is constant here also. This is the epsilon naught value. Epsilon r is already 1. So substituting, you will be getting this equation. And you know the vector, unit vector. I have already told you how to determine 20 minus 0 into I bar, 0 minus 20 into j bar, 0 minus 0 into k bar, by square root of this square plus this square. So this is the answer. And next one is from C to D. C is at 20, 20, 0, and D is at 20, 0, 0. So how to determine? So the distance is 20 minus 20 whole square plus 0 minus 20 whole square plus 0 minus 0 whole square, completely square root, 0.2 meters. Unit vector will be 0 bar, 0 I, minus 20 j, and 0 k. Okay, by square root of this thing. So you will get minus 900 j. Okay. Now the resultant force is a summation of all these forces. If you carefully see, the first one I have got 900 I, the second one is this one, and the third one is this one, minus 900 j. Adding all these things, this is my electrostatic fields. This is the magnitude. So magnitude of this one. So and so the magnitude, if I consider only the magnitude of this one, so I should write it as 1216.8. So I must consider the magnitude of this vector also actually. What is the magnitude of this vector? Square root of 1 square plus minus 1 whole square, right? 1 square plus minus 1 whole square. This is my actually magnitude. Don't consider that this is the only magnitude. You have to consider the magnitude of this vector also. This is not a unit vector, right? I minus j is not a unit vector. So that's why I'm considering its magnitude also. So you will get somewhere around root 2, I think. So this is the 1216.8 into root 2. This is the magnitude. And coming to the direction, if you want the angle, and what you can write it as 1216.8, comma, y coordinate is minus 1216.8 and z coordinate is 0. Okay. You can compute the angle of also that. Now, moving on to problem number 2. In the problem number 2, if you carefully see, this is the question. Calculate the force on unit positive charge, which is at P on the x-axis. These are the coordinates of point P. And the field is created by two charges. One is a positive charge of 1 nanocoulomb, which is situated in air at the origin. And there is another negative charge of minus 2 nanocoulomb situated on the x-axis. See how the figure will be. The figure will be like this. Here also I will consider z-axis is not mentioned, so I will take it as 0 defaultly. So this is x-axis, this is y-axis. Once there is a point P, its coordinates are x coordinate is 2, y coordinate is 0, and z is defaultly 0. And he says a positive charge is situated in air of the origin. So I'll take it as O, origin, 0, 0, 0. Here there is a positive charge plus 1 nanocoulomb. And he says there is another charge, Q2, at 1, 0, 0. And it is minus 2 nanocoulomb. So he wants to compute the field at this particular point. So two charges can develop a field. One is EOP, the other one is EAP. Okay, so these are the points and these are the charges which I have mentioned. So assuming a three-dimensional Cartesian coordinate system, the points coordinates will be P will be 2, 0, 0. This is origin 0, 0, 0, and this is A 1, 0, 0. And Q1 is located at origin, as we have already mentioned here, and Q2 is located at A. Okay, so and my point of consideration is P, which is at this location. Now, first of all, we'll compute EOP. So we know that basic equation how to write 1 by 4 pi epsilon naught epsilon r into unit charge. So sorry, it's a point charge, so I'll directly take it as Q1 in this case by r square, where r is the distance between O to P into unit vector of O. Epsilon r, since the medium is air, I can directly take it as 1. Epsilon naught value, you know it. Q1 value also, you know it. It has been given 1 nanocoulomb, and the distance, you know, origin is at 0, 0, 0 and P is at 2, 0, 0. So the distance between these two, 2 minus 0 square plus 0 minus 0 square plus 0 minus 0 square. So it is 2 meters. So it has been given. So EOP, this is EOP. And okay. Now, substitute. So what is the value which you are getting here? You are getting somewhere around 2.255. Okay. Now moving on to the second one. Now here now I do have the charge at A 1, 0, 0, and the point of consideration is 2, 0, 0. So again I am determining the distance between these two, and again I am computing the field due to charge at A at point B. So the procedure is same. The only difference is that the charge here is a negative charge. So do it carefully and see the answer. The answer is minus 18. Now what I am supposed to do? I am supposed to add these two, the EOP and the EAP. So earlier it was 2.25i, now it is minus 18i. So the answer will be minus 15.75. The magnitude of E is 15.75. And the direction, how this is the xy direction. So minus I means it will be in this direction. Okay, so that's it from my side. Thank you. In the next class, we will see the electrostatic field due to continuous charge distribution. Okay.